Asked him. Hello?
Hello,
Hey,
how are you?
give me a few minutes. I'll set up this room.
Okay.
Okay. And you can see some of the others. They're arranging the room, so give me. Sorry, I didn't. Everything around. So.
Hey, Jordan,
Hey, what's up?
you remember me?
Yes, of course.
Move this table around. One student, two students here. It's 6, right? And 2 there, like 1 on the table there. That's right. You guys can move this. Yeah. Two of you can sit on that side, and then ask people come here. By the way, I'm Shakesh.
I'm Luke.
Luke.
Rob.
Rob. Okay. Nice meeting or like seeing your faces, like had your names on the. So please go ahead and maybe one can sit right on the corner of it, if you don't mind. Either. Is that possible? Is that convenient? Sitting. I will be teaching here. That's the point.
Okay.
Okay. Right. So.
If I turn this around, I can sit.
Sure. Feel free. I mean.
Because I think that if I get this desk moved around, you could probably sit there and I can sit at the end of this one. I'll probably have to sit further over to see.
Yeah, I know. So You get my point, right? Even I haven't. I don't have a complete.
But I would bet you that
Maybe you can push that laptop here.
Yeah.
Maybe.
Thank you so much.
that should give you a semi-comfortable spot.
And do you just share it or?
Oh, I've got, I can, yeah, I can get that out of your way. We'll see how many times, even with the professor in the room, I'm still the oldest guy.
I'm like, what they say? Age doesn't matter, but I'm old, so I cannot say that, right? And feel free to come in, at least 2 of you, but maybe 3. Oh, it's a Jordan. Oh, Khalid, you're also there. We cannot see you. Do you have a video?
There he is.
You're across the world, huh?
Yeah. Yeah. Thank you very much.
Yeah.
How's it going, guys?
Yeah,
Good.
So we have about 3-4 people. I can show you the.
How's it going, Jordan?
Hey, good. It's nice to see your face.
Same here, man.
Yeah.
Show you the students, maybe. If I can. Here you go. There are 2 of here. So you can say hello to them.
So, what are your names?
Hi there.
I don't know you guys.
I'm Luke. I'm new.
Luke and
I'm Rob. I'm old, but I'm new.
hey, no, I'm old too. Don't worry. I'm 34, so I'm on the wrong side of the years.
52, so
Nice seeing you guys. Nice to meet you.
you can take your age and add somebody in here.
Okay. Hey, Jordan.
Hey,
How's it going?
not too much. How are you?
Pretty good. Let's look forward so that we're heading.
Moses, which courses are you taking?
Math methods, this one, and quantum 2.
Oh man.
Yeah, I noticed you're not doing quantum 2.
Yeah, I'm doing 2 research hours.
Oh, okay. That's cool.
I figured the 3 stack wouldn't be so great for me, so.
Yeah.
They put me in a 575 class instead of math methods.
570.
Yeah, the 2 research credits. They usually do that, yeah. Is
I've
your-
got 5 years, so I'm not in a rush.
Yeah.
What are the rules about passing papers? I mean,
So if you're wondering why I'm on here, just so everybody knows, my wife is a teacher in Missouri, and she will be going back kind of full time, full steam ahead in like a germ and virus infested places. So trying to minimize my interaction between two places as much as I can. I'll have to come for labs, but trying not to, expose everybody. If her school gets, Missouri is a little bit different than Illinois is. I think most schools in Illinois aren't going back. So.
Hope you are getting well soon.
What was the meeting password?
IH bar. IH bar. All small. B-A-R. And the H bar. I'm not asking. We're not done the settings here yet, so I will keep moving around, so hopefully later on. Oh, that's already here for those who are online. Oh, that's Moses. Hello. So you be Michael. Michael. Suresh. That's over here. Okay, guys. Let's see how efficient this would be. I can do settings on this, but I think since we are already late, let's use one book. So I'm Shatesh. Is this visible on that side? Across the. No. Jordan? Hello? Readable? Oh,
Yes.
Okay, yeah. And feel free to keep the camera on. I think it's only a few people, so unless you guys want to keep it off, that's different.
No. I'll leave mine on.
Yeah. You're welcome to put it off, but it's nice to have faces.
I just have to mute from time to time for my dogs.
Yeah, sure, yeah. Okay, and this is physics, right? Here it is. 520A, electromagnetic theory. And I passed on a syllabus attachment, and the first homework. For those of you who are across there, I think the website is www. I think that's not needed. This is SPH, that's for spherical, and then ICS, harmonics, like last three words of harmonics and first three words of spherical common. And if you click on there, then you should get a link for this course, physics 520A, and you should be able to see a syllabus there on first paragraph, I think there, and the homework one is also available there. This time in the first week, I'm passing on the homeworks. The expectation is that you just go to the website and get it there at your. But I will announce about the homework. So the first homework is due. Homework one is due in 1 week time, so it will be 24. And
So I saw that you have it posted on the webpage, but when you actually click on it, it just takes you to the not found page.
oh, so I guess I forgot to upload it.
Yeah.
because it was done at the last moment. So I will be doing that very quickly right after the pass. If you don't see it within 1 hour or so, even half an hour or so, feel free to send me an email.
Okay.
Online email.
I'll
Yeah,
just
it's
remind
okay.
you tomorrow if it doesn't go up.
Yeah, by the way, yeah. Yeah. Thank you for letting me know. Just to tell you why a website outside, mostly because our server went down, I think sometime in the spring semester, and then it never came back. And at least the physics department server had the home page on. So this is a private web page where I basically migrated the whole file. So eventually it will come back, and then we will have it. But it serves the purpose, so I think it's okay. Okay, about the course, I don't have a syllabus for myself. Huh? Okay, so let's see. I think with this infrastructure that we have, we should be able to have the course running reasonably smoothly, and I see that most of you are here. So I was not expecting this full attendance because half of you guys did not reply to my email. So I was estimating the number that will be coming in. So, but this is nice to see you guys. I think it is a lot more efficient, at least for courses of this kind. But I do know that safety is very important. So, so no issues about those who are across the internet. But thanks for coming into the classroom. So I think we should be able to run a reasonably smooth course in this manner. Last semester, even with the almost at the switch of a button, we switched to online, and the office were prepared. I think we managed it well. Would you say? I think Moses and Jordan, you were there. I think we managed it reasonably well. I'm sure those who were across, it could have been better, but I think the course went, as far as the stuff to be covered, everything we could manage it well. So with that as the only experience, I think we should be able to do a reasonable thing during this semester also. The only requirement I will have is that assessment becomes hard in an online process. So during you guys are there for classes itself. So for the exam, you have to be physically present. We can make it in 2 different rooms. We can make arrangements so that everything is safe. So the exam, unless it is an take-home exam, that's it. I haven't decided that yet. I do give a lot of take-home exams during a normal semester, but we'll see how it goes. Usually it depends on what's the response from the homework. If the homework has a very good response, in the sense everyone is participating in it very well, then I have a good assessment during seeing the homework itself. Then I don't care for the exam much. But if I see that no one is doing the homework, or it's not showing the person's performance completely in the homework, then I try to do the exams more seriously in a stricter manner. Otherwise, I just make it a take home and treat it like another homework. Again, I think 3 of you have been in my course earlier. You have partially sat through the course. So I think you can talk to them. That's one more thing I would say. Okay. Office hours. I will be available in my office during my office hours. I think one person is okay to come in, and that is all during office hours. Typically, it is 1-to-1. And otherwise, if you feel you should do it on Zoom, I will be available on Zoom also at that time. So let's see how it how proceeds. If there needs to be more than one person, then we can switch on the Zoom again. The only challenge I see is that every time you have to assemble this again and again. Last semester it was very easy. It was sitting in my living room permanently. You just click a button and you reach there. But here you have to carry the whole baggage with you. So maybe I'll get more efficient with these things as we go. So office hours, that might be the only challenge I see, or even the classroom. But again, you usually find simpler, easier ways around as we proceed. So that's office hours. What else is that? Website I showed you. That's the website. I think it will start writing darker as we proceed. So hopefully it is more visible. Okay. About the course, let's see. We will mostly do electrostatics. I'll talk about the course itself in a few minutes. But before that, let's do the logistics a little bit. The textbook would be the textbook. There's classical electrodynamics. By Schringer, and there's Girard, 4 authors, Melton, and this 4 authors. C. Sorry. E. S.
AI.
S.
SAI.
So having said that, expectation in the course is that you do go around outside the textbook also. From the past, what I've noticed is that just attending the lectures itself is a good, that's where you begin from. There won't be a one-to-one correspondence between even the order in which topics go between the textbook and this. But I can assure you that at least in this course, everything that I do is probably there in this textbook. But this textbook is not the most friendliest textbook. It's a very good textbook, but it's not the most easy to follow textbook. But the subject is hard. If you spend enough time, this is an extremely good textbook. Schringer is a Nobel laureate. This is based on lectures he gave in UCLA. And Belgian was a student. He is the person who I think they were postdocs in UCLA. So they compiled this book. So very good book. I almost follow the book everywhere. So in a sense, every notation, everything should be there in this book. But you will see that as we go, it may not be. There is no line-to-line correspondence in there. So. But that's a challenge in any subject in an advanced level. You will have to start reading books or figure out how to find the content. But feel free to use the internet, use the textbook, and there are 3 more textbooks I've suggested, textbooks in the books I've suggested. I have used most of them, but again, this is almost everything that I do probably is there in this. I don't follow it line to line, but I have learned it from that. I'm sure it is there. So that's about the textbook. It's worth buying it, but even if, as I said, the homework questions will be typed in a paper and given to you, it doesn't follow any particular problem in the textbook. So I have seen students surviving without a textbook either. I don't recommend it completely. You should at least follow one book. I don't particularly say that you should follow this textbook, but it's a good thing. If you're going to be in physics, at least have a textbook on electrodynamics. I think it's good to have. So that's on the textbook. Again, homework will be posted here also. And what else is it? Yeah, and then comes assessment. So there will be, let's see. So there's going to be homework, almost every week or maybe sometimes 10 days. Usually I try to make it every week. Sometimes it goes 10 days. So by the end of the semester, you will have about 10 to 12 homeworks. So let's say 8 to 12 homeworks. That's how it goes about. And all those homework will amount to about 30% of your grade. So that means each homework is worth about 3% if you assume 10 homeworks during the semester. Then there is what I call extra credit. I'll tell that more in a few minutes, but this is going to be 5%. So this is slightly different from what I've done earlier. I used to make this 0%. That's why it was called an extra credit, but I'll still call it extra credit, and you'll see why it is extra credit in a few minutes. But let me come back to that after a few minutes. There'll be exams. There'll be midterm exams. So there will be 3 of them. So that's a 3. When the classes were happening in the normal way, I used to have 2 exams, but I made it 3 just in case there are issues with exams or anything like that. Just for being on the safer side, I made it 3. As we go into the semester, if it seems like it's not necessary, I might drop myself. I'm very flexible. The class is small, and again, you guys should take initiatives and talk about, oh, I want it this way, I don't like the exams, like more homeworks. Talk to me about it. It doesn't mean that I'll completely listen to you immediately, but it helps to have those kind of feedbacks also. It's about logistics, but you'll be surprised. It really helps me to have what you guys would like to. So feel free to talk about that. So midterm exams will be 15% each, so that's about 45%. And there will be a final exam. That's 20. So that's the distribution. And again, remember, this will be your most important thing, homework. So spend a lot of time on it. It is not going to be easy. And what I've noticed, I mean, if you have heard about electromagnetism or electrodynamics courses in other places, usually they are one of the hardest courses a student first encounters. It's not that there is nothing harder, but usually electrodynamics is one of the first hardest course that you encounter. The homeworks are typically hard. If you, especially Jackson's homework are very popular. Have you guys heard of Jackson? So that's another book. It is a recommended book. So it's Jackson Electrodynamics. So if you go by graduate programs across the nation or across the world, this is the most popular book if you go by statistics for electrodynamics, and it is it's respected a lot. It's reputed for having very tough problems. So that's how it works. Now, what happens? So how are my homework problems different from this? So many of the problems will be from Jackson or Schwinger, but what I do is that if you give a problem just in 4 lines, it's extremely hard. But I break the problem into about 10 or 15 steps, and each step will be very easy. So it might seem like when you're doing the homework, oh, it is so smooth, you're able to do everything, but you're practically doing a very hard problem, but I'm guiding you through. That has advantages and disadvantages. Advantages that, of course, that you're able to do a problem that otherwise it could have been, you wouldn't have even been able to shut, or some of you might not be able to shut. So, and the negative side is that you don't get the feel for thinking about a problem in the unknown. So it has advantage, disadvantage, but that's what I do. I've noticed that it helps a certain set of students. Maybe some of the students would like to not know the detailed steps and work from the very start from a small segment. So if that is the case, read through the whole problem and give it a thought on your own. Don't look at the step. That's one small thing I can suggest. But again, it will take time, but it is supposed to take time. It is you'll notice that midterm exams, everything is sort of related to the homework. So if you what usually I say is that if you can do the homework on your own, like you attend the lectures, go back, you're able to do all the homework on your own. No internet, no textbook, you don't open anything, and you're able to do the homework, you're relatively prepared for the course. You're doing good in the course. That's an assessment. But if you're using the textbook, nothing wrong, you should use the textbook. The expectation is that you won't be able to do the homework. You will have to open the textbook. You will have to go to the internet. But track that, how much you're using. If it is a little bit, or you go to the internet and you see a statement written about the homework and, oh yeah, it makes sense, and then you're able to proceed. That's good, that's very good. But if you're not able to, you spend 1 hour on the internet, and a textbook and everything, or let's say 3 hours you spend, and you still have no idea of what the problem is asking, that's a danger zone. So then you should worry that whether you're getting the concepts or not. So it's sort of self-assessment that you should be able to know how much help you're taking from outside. I recommend you to take it outside, but I'm not going to ask you how much help you're taking. That's your own gauge, and you should assess yourself. The only remedy for that is that you spend in more time. If you're using 3 hours, or if to understand the problem, if you have to spend 3 hours outside, that means you have to spend more time studying this subject, so that it becomes next homework, it becomes easy. So that's a small guideline for how you could proceed in the course. Again, homework is the important part. The first midterm exam is about in the 4th week. It's on a Monday. I think it's written in the syllabus. So it's on. I think all the exams in this course are on a Monday, like every 4th week, 4th or 5th week, maybe on a Monday. Now, extra credit. Now, what happens is that so I am good. Let's say that you worked on all the problems and you got 60% out of, so you got 60 out of 100. So that's a total you get. That's a little low, like usually, but at the same time, it's not extremely low. The grades in this course could depends on if you go by the last 4 or 5 years, it can vary typically between 40 to 80. That's an average, can change also. So even 40 is not extremely bad. And I'll see how this can be this can be curved. So now, what is extra credit? Now, during every lecture, I randomly come up with random questions. For example, let us say this is the first class. You can say, what are Maxwell's equations? Right. So I can ask you, how many of you have heard of Maxwell's equations? Like how many of you can write down all the Maxwell's equations?
I write them down.
First, let's go back. How many of you? There are how many Maxwell's equations? Maybe. Also, all of you know that, right? So,
There's the 4.
so let's. Yes.
4.
4. Yes. Thanks. Yeah. So, so the example could be that, okay, I could say, go and look up Maxwell's equation. Right? That's it. Okay. Now, the question is not very clear. What do I mean by go and look up Maxwell's equation? You go back home. So first you note down, you mentioned something these days, your video. So that helps. You can go back to the part, but you'll be surprised that going back and looking the video is very time consuming. At least that's one thing I realized, that this is not the most efficient thing. Going back and searching where since this is a course you're investing time on, so probably you have more time. Go and find out the question and rephrase the question in your own words. So extra credit involves you're framing your own questions. Right? So I have a guideline, Maxwell's equation. So you can do, you read about it for how much ever long you want. Don't spend too much time, especially
don't write a thesis on it. What I expect is a very brief, like 2-3 sentences on it. For me, it is for you guys to go and think about the whatever I mentioned. Let's say, is negative mass possible, right? That's a kind of curiosity question. Can mass be negative? And you can go and think about it. Now, the answer may not be that easy. I mean, there might be all kinds of answers. Even if you thought about it for the whole night, you had sleepless nights and you have nothing to write, that's perfectly fine. Just write a sentence saying that I thought about it, but I had nothing to write. That's good enough, and you will be qualified for the full points. Okay, so it is more of for you to go back and think. But I do want that paper back, notice, because I'm giving you 5% for it, and those who have been in this classroom before, they will know that just writing the question is good enough. I'm not going to question your, oh, did you really spend time on it? But be reasonably honest. I mean, all of you guys have been honest in the past. So it is more for making you, it's sort of a discipline in the course, how much you go back and do you open the book at least. That's my way of looking at it. Okay, you open the book and you at least have the question. Now, since usually what I ask is that you write on a paper and give it to me in the next class, that's how you do. But this time, some of you at least are not going to be there. So there is a provision in D2L where you can upload this homework. So it's reasonably easy. If you go now to D2L, you should see an assignment. It will open up right after this class, right at 12:15. It opens up, and you can just upload it. Like spend a few minutes on it, even if it is 5 minutes, I'm perfectly fine. I would rather say that don't spend too much time on it. Like the questions are not well defined. The questions are there to motivate you guys. Now, if you guys are motivated, that's your issue. You guys handle that. I'll be glad if you're motivated. But at the same time, you shouldn't come back and tell me that I spent 3 days on thinking about that and I wasted all the time. So be judicial about spending the time on it. I expect you guys to spend only 5% for the grade, for the subject, for the topic. That's your call. So that's the way to put it. But do submit it. It's a matter of discipline there. I've noticed that everyone misses that when it comes to every lecture, writing that every day and submitting it. I've noticed that people do miss. But now that there is 5% grade to it, and there is more to it, okay, that plays an important role. So it's just, again, for me, it is that you're going back and opening the notebook and at least thinking about what happened in the classroom. In fact, the question is list the questions that were posed in the lectures and write a brief answer to them. Now, let's say that there's a student who got a total of 60% out of all this, plus let's call this Y, right? So let's say there is a Y, you got about 100%, like let's say 75%. So that's 0.75. So Y will be something, so you got 75% of all the extra credit, so I put Y is equal to 0.75. Now, how does this help you with the total grade? So this is a little low as far as I'm concerned, so I try to curve it, and this is how I will curve it. I'll take 60 and then subtract 60. This is the points you lost. Right? If I give you all the points back, everyone gets 100 points. Right? Now I'll multiply that by Y. You will get back the amount of points you've lost multiplied by Y. And then I decide a uniform number for everyone, which I'll call A. That's going to be your curve. So I decide that I'll do you 50% of all the points you get back. So let's say this was not there. So everyone gets 50%, let's say. So that's a number I decide. Typically, it is only 20% or so. Like from the last 2-3 years, I've noticed I give back about 20% points or so. But then to get back all of those 20%, you have to have Y equal to 1. If you have not done very well at extra credit, you lose. So there is a Y here. right? Usually you don't get this full points if the y is not 1. So it helps you get all the scores back. And again, this is a little exaggerated. I don't give 50%, at least in the first year that I taught this course, I gave 50% of the points back. But since then, usually it is about 15 to 25% of the points back. And this is you decide. There are cases when this is 0, and then there are cases when this is 1. Many of you, it's very easy to score 1. That's a good. But usually, I notice there are some students who say that no, I don't want this points at all, and you see all sorts of things. But there's an easy thing, it's just a small discipline needed in there. Any questions on that? So could be confusing, but again, as you go, how about this? Today we need a what do you say? Extra credit problem, right? So what is y? So that could be an extra credit problem. It's nothing to do with electrodynamics, but still. Or I can have a better question actually for extra credit. How much error, or how will you measure the error in grading a course? By grading a course, I mean, usually we say after this whole course, you get an A, you get a B, you get a C, or you get a D, right? Or sometimes you can make it more precise. You can say you got a 92% in this course, right? That's how eventually that's the number you get, right, from this course. Someone gets 76%, someone gets 92%. So the question is, how would you go about estimating the error in grading? This has nothing to do with this course, but we are all students. We should address this question. Our students are, I'm an instructor, but I'm also a student in a sense, learning. All right. So ask the question: how would you put an error bar to that? How would you make an error bar? Is the question clear? And again, as usual, like you can ask your question, like post the question on your. Okay, so that's what it is, and then the reason. I guess I covered everything. Regarding logistics, anything, any questions you would think I should have addressed? Yes, please.
What, it looks like this is done in tech.
Yes.
Do you want the homework submissions in tech, or does it matter?
No. I would rather discourage using tech. You're welcome to use it, but it takes a long time to type it. Handwritten. So nothing can beat that. I mean, I'm pretty efficient in LaTeX, but I think hand cannot be beaten. Like significantly there, I think, at least when I write and type, I think it's 10 to 50 times. So I wouldn't encourage you guys to LaTeX it at this point. At least that's not part of the course. So I would, but separately, yes. It's a very good tool. All of you guys should learn. If you're not used to LaTeX, like what Rob, right?
Yes.
What Rob is pointing out is LaTeX. Right. So this is it's very popular to use Word. Microsoft Word is a what will you call it? Document creator. Is that the word? Word processor. Yeah, word processor, right? Yeah, word processor. Yeah. So yeah. So that's why it's called Microsoft Word. But you would notice that so there is Microsoft Word, right? MS Word. I think these are the two popular ones there. Now, if you're preparing a one-page document, let us say even 3-page document, you write essays, you write homeworks, all that. Microsoft Word is a lot easier, right? You see what you're doing. This is a lot more easier. But if you're writing a book, you're writing a thesis, your master's thesis, and all, nothing can beat LaTeX. Okay, LaTeX is a very good software, so you should learn it. If you're going to do anything serious, if you're going to ever make a serious document, LaTeX is the way to go. Equations become extremely easy if you use MS Word. Equations are not easy. And the best part is, I think, in a document, what happens is that in the third chapter, you're referring to some equation in the first chapter. So you've written, let's say, 10, you have 5 figures, 10 equations, and in between there are lots of things you want to refer to. And when you want to go back and refer to, say, equation 1, that's okay, you can write equation 1. But then 1 month down the line, you might decide that, no, that's not what I want to have my equation 1. I want to have one more equation before. You cannot renumber it. It's just not efficient to renumber that. So there are easy ways to do that. There are the same things are available in MS Word also. Like earlier, it was not there. But you can do most of what you do in LaTeX on MS Word also. But this is meant for that. So it is a lot more powerful in that sense. These days, MS Word can do a lot. Can capture a lot of things that LaTeX can't. But this was meant for doing that. This is much more powerful in that sense. So again, if you're going to if you think that you'll be writing serious documents, LaTeX is a good thing. But in this course, I'll strongly recommend handwritten things. You want to think. Don't worry about formatting. So when you're writing, you're thinking about at least a little bit of your effort is going into formatting. So let's not have any distractions. Handwritten notes, and if you are to submit it, since many of you are here, you can submit me hard copies. I would like that, but those of you who are not going to be in the classroom, you can submit it on D2L. So again, like I said, for extra credit, there is a submission process. I will create one for each of the homework. It will be due. Usually, I have it due at 4 o'clock on the day it is due, because the physics office opens until 4 p.m. But these days, because it is going to be online, I made it due right before the class. So again, let me know if you think it is not it is inconvenient, then I can change things. And these are the matters where you can ask me. If you're, as a whole class, if you think that the homework should be postponed, that is too hard, but first talk to each other. Don't come to me individually that, oh, I want to postpone, homework postponed, that's harder for me to do. But as a whole class, if you tell me that, oh, the homework was too hard, half of the students did not make too much progress, or we had something else going on, there was another exam. But as a whole class, if you come to me, I'll most probably postpone it. Again, those of you who taken the course with me before, you know that I'm reasonably flexible. But at the same time, we want to cover the material also. So let's not get slowed down by the homework, but at the same time, feel free to talk about it. So, yeah, so yes, any other questions? Yeah, so let's see. So let's do some little bit of. So I should at least write down the Maxwell's equation. Let's write down the Maxwell's equations. And even though we will start with Maxwell's equations for most of the semester, we will be using only 2 of those equations. So we'll be doing electrostatics for some time. And next semester is when we really get the full strength of Maxwell's equation. So anyone remember, anyone can tell me the Maxwell's equation, let's say the first equation, first Maxwell's equation, anyone remembers? In any form.
The Gauss's electric field.
Yeah, how would you write it?
Uh,
So you would say Gauss, right? Gauss's law is called, I think. You write S there?
the
No.
divergence of the electric field is equal to
Yeah, very good.
current density over epsilon naught.
So that's an electric field. So this can have position dependence and time dependence. That's equal to, this is charge density. And that is, that familiar? In the differential form, is that familiar? In the early stages, like in the elementary or introductory physics courses, you see this in the integral form. This is in the differential form. What is the integral form of this? Is this readable, by the way, on the other side?
Yes, it is. It's a little blurry, but
Ah,
I don't
little
know if
blur.
it's because of the shiny board or if it's maybe not. Yeah, that's more readable.
Okay. What is the integral version of this?
Integral of E dot ds is equal to, this is surface integral too.
Good, very good. So that's a surface integral, so it's a closed surface. Dotted with dx. So this is a surface element. Surface area element, maybe. Area is a vector, so that's a vector. So what's the direction of area? Is area a vector or is it a scalar? Is area a vector or a scalar? Scalar. Vector or scalar?
Vector. Is it a vector?
That's a question I'm asking. So I want to pull a better others.
We put a vector over the surface element, so I'm guessing it's a vector.
So Jordan says vector. Scalar. Scalar. Right?
We're
I think
using
it
it.
could be both.
It could be both. Okay. Elaborate on that. Could be both.
I guess, I mean, Rob, you just said like it depends on how you're using it. So I guess that's kind of what I would say as well.
So I think you guys mean by like velocity. Velocity has a magnitude.
Sort of. Oh, I see.
I mean, the surface can change, right?
So here's how the area is a vector. Area is always a vector. Often, or until we come to college and all, we typically learn it as like, especially in the first time we learn it as area, length times breadth. That's a magnitude. It's like saying velocity and speed. For quite some time, we always work with speed. Speed is good enough, right? But velocity is more than speed. Right? But speed is also perfectly well-defined concept. But velocity is more than speed. It has some direction associated with it. Same thing with area. You can survive with the scalar version of area, which is basically the magnitude of the vector associated with it. But area is a vector by construction. But it's often okay to work with the magnitude of it. So then comes the question, so what's the direction of area? So let's say this blackboard has an area, right? What's its direction? What do you mean by direction of an area?
It's the vector normal to the surface.
It's a vector normal to the vector. So given any surface, you can define a normal perpendicular to the surface. But then there's a confusion, right? Is it this way or is it that way? Right? And that's there's a small ambiguity there, but typically you can have a closed surface. So this is a closed surface, and if you, let's say, that's a small element of area, and then it comes in the outward direction. So once you have a closed, there is an inside and an outside. That's reasonably, that's not ambiguous, and it always points in the outward direction. If you're in a situation like this board, which is perfectly flat, let's assume that this is perfectly flat, then there is an ambiguity. So then you have to have a choice. Now, typically what happens is that even in that case, you can get away with that ambiguity, and that's done in the following way. Let's say, oh, can you guys see? Oh, you guys cannot see what I'm doing. That's it. Okay. Please remind me whenever I get to put the camera in the right place, and these are settings. I'll eventually make this faster. Today I was too occupied in arranging it. Yeah, so what I was trying is that, yeah, so like I said, there is a flat surface. It seems like that is an ambiguity, but even that we can get rid of it by a notation, and that's in the, so let me ask a related question. So let's say this is x hat, and that's y hat. And now let me ask, in what direction is z? Is it coming out of the board, or is it going into the board? Or it does it on random?
It's coming out.
I mean, so Moses says it's coming out of the board.
For a right-handed system.
For a
Right,
right-handed
right.
system, that's exactly, that's a very good, the proper complete that Moses used that to get the right hand. So it is coming out of the board, and what does right-handed mean? There is a cross product, right? We all have learned cross product, A cross B. So Z hat is by definition always Z hat cross Y in a right-handed system. Right-handed. If it is left-handed, then it will be going into the board. And often notations, once you bring in a notation, half of the world doesn't uses it left and half of the world uses it right. But this is one of those universal things, everyone does it right-handed way. And it's necessary that once you stick to one, you have to live with it. So in that sense, if you have a flat board, if you have a flat board, again, if you have X and Y chosen, then you can actually associate a direction to that. Okay, so that's the surface element I was talking about. Here, that's the same electric field, and this time, what is the right-hand side? So, how would you complete that? What is that equal to?
1 over epsilon naught times the integral of the charge density dV. So volume.
It is the integral of charge density. So first you have to have a, so when we say this is a closed, so there is a volume. So this circled integral means this is an integral surface enclosing the volume. So pick a volume, let's say it's a finite volume, and this enclose, so any surface can enclose, or given a volume, there is a unique surface that encloses the volume. It doesn't have to be connected. Sometimes you can have a hollow sphere, and you can have two surfaces to it, but there is a unique surface that does that. And on the right-hand side, you have to do the same thing, volume, but this time it's a volume integral of rho. And what is that equal to? If you add up all the charge density, so this is a charge density. So that's charge density. That charge density is charge per unit volume. So if I take a finite volume and integrate over charge density, what will I get? And you'll get a charge enclosed in that volume. So this can be written instead as charge enclosed. It's not any charge. It is the for a given volume. What is a charge that is enclosed in that volume? So that interpretation is important. Notice the difference in this. This is talking about a finite region of space. There's a finite volume. You integrate over all that, and you get the charge enclosed in it. On the left-hand side, this is a point-dependent quantity. At every point in space, you can define a derivative. Divergence is a sophisticated version of a derivative, a lot more sophisticated actually. We'll talk about that. It says that divergence of the electric field is equal to the charge density. So it's extremely, one should, hopefully by the end of the semester, you'll have a good idea of what that means. That's should be one of our goals. Okay, so that's Gauss's law. This is the gradient operator, by the way. So that's here. We'll talk about the first week. We'll warm up our.
I think if you zoom back out on the video, we'll be able to see everything. I think it'll be okay if you zoom out instead of having to scroll around.
Yeah, I will make this better like last semester. I will do the settings of it.
That's good.
Okay. That's the gradient operator. Are all of you guys familiar? Right? Have you guys used it? I'm sure you have. Now, one of the things we will have to start working in this course is just to give you a what are the kind of mathematical techniques that we will be learning. Notice this is in rectangular coordinates, right? I, J, K is appearing there, X, Y, Z is appearing there. Very quickly, we want to be independent of any coordinate system. You can write this in spherical coordinates, you can write this in cylindrical coordinates, perfectly fine, but that's a tool. We want to be able to have an interpretation of gradient independent of the coordinates. That will be the perfect goal, but usually it's not easy. So don't worry if you're using the rectangular coordinates or cylindrical coordinates or spherical coordinates, but the goal is that you get that field for this gradient operator right without independent of all this representation. So what does divergence of something mean? What does gradient of something means? That's the goal, a mathematical goal you can have for this course. Okay, so that's Gauss's law. What's the interpretation of Gauss's law? Anything you can tell about? What impressed you? Like anything non-trivial you can say about Gauss's law? What is big deal about?
It tells you that the electric field strength around some region in space is directly proportional to the charge enclosed or the charge contained in that region, I guess.
That's correct. That's correct. Yeah. So that's using this interpretation, right?
Mm-hmm.
Is that whatever Jordan said? Is that roughly? So what he said is that let's say, okay. So let's take an example, right? So here is the counterintuitive part of this. So let's say there's one positive charge in both universe. We just have one positive charge. So that's Q. And what is the electric field associated with a point charge?
Radially away from the structure.
Radially away. There is no time dependence there. What is the formula for this? Yeah, it is radial. What will you write? There's only one point charge. What's the electric field associated with that? What is it? Anyone? Maybe the question.
1 over.
Yeah, 1 over
4 pi epsilon naught.
Yes. So you would say this is Q over R square. I'm sure all of you guys know this. I think it was too obvious. Right, that's Q over R square. Now you will see that. Yeah, so this is where one more comment. I gave you some books, right? All of us have studied about the issues about units. Some books work in centimeters, some books work in meters, some books work in feet. That's all old, but now we'll have a more serious problem that equations look different in different units in electrodynamics. Not just units look different. If you notice, when we use, whether you use feet or meters or any units you use in the old until you reach ANM, equations look the same. F equal to MA is F equal to MA in any units. Right? You never say that, in meter SI units, my F is equal to MA, otherwise it's different. But here is a new play things. Equations start looking indifferent. So when you use two different books, I will be using SI units, and that's a challenge, by the way. The textbook does not use SI units. Right? So textbook would write it like this. So there's a simplification in there, right? No doubt that this is simple. The textbook likes to do this. Right? But I will use SI units. So there will be 4 pi epsilon. And you will see that all through the semester, we will just be writing this again and again and probably wasting ink. But that's the only purpose there. And that's the reason that someone later on thought that, oh, why have that at all? Just set it to 1. Right? It has meaning, but let's stick to SI units. There are advantages to that also. So let's stick to it's exactly the argument like what's the advantage of meters, seconds, and kgs over feet. What is the heat, like hours, and so on. In principle, nothing. Like if you stick to it, if you're good at converting, there's perfectly nothing wrong in that at all. Each one might have advantages. But if all of us use the same thing, there are from simplicity, convenience, especially when you're learning the subject, it becomes very easy. You can use 2 different textbooks. So learning part is the big convenience. So, but we'll have to live with this. Half of the textbooks in ENM do not use ENM, SI units. Mostly it is engineering textbook will use SI units. All the physics textbooks, all the serious physics textbooks prefer not to use SI units. Just because it's unnecessary. People think it's clutter. In an equation, there is a lot of clutter. Like there is no meaning or there's no information content in there. So why not? So look into this. So get used to converting it. At least one good part of the semester, we won't be using a lot of Maxwell's equations. So it will be just this 4 pi epsilon. So that's easy to get rid of. You can transcribe to equations very easily. But as you get into the next semester, it will become hard. It is not very obvious to go from one to the other. And one of your homework will be to go from one system to the other system and how we go about that. So it's a little messy, but I wanted to do that. Yeah. So that's electric field, correct? And as one of you pointed out, Jordan was saying, this is radially outward. So that's a chart. So it's very straightforward, right? If you get rid of this 4 pi epsilon, which is just a number, right? Is inversely proportional to R. It's proportional to charge, and it's radially directed. It's a vector field. So charge comes with these lines, if you want. It's an abstract set of lines. You cannot see these lines if you have a charge sitting in there, right? That's how the electric field looks like. The 1 over R square, how do you see that in here? The density of the lines go down as you go farther and farther. So if you take a fixed amount of volume, the number of lines that pass through it decreases, and that's the 1 over R. That means it's getting weaker. More number of lines means it is stronger. Proportional to charge, so if you have more charge, this intensity increases. But it is always relative since the number of lines you draw is scaled. So if you draw more number of lines, it's only relatively you can speak about the number of lines. So think about that. So that is proportional to that. And now, what Jordan was saying, what does this mean is that if I were to have so this is an abstract, so this volume is my choice. This charge doesn't come up with the idea of volume. So this is any volume. if I take this volume and calculate electric field, so electric field now is like this, is electric field going everywhere. There's some coming here for every element, so so the surface element will be there. Is that clear? And that's the electric field. At every point, there's an electric field, and there is a surface element. Take the dot product of that, and then add up on the whole area. Take any closed surface and do that, and it tells you that whichever surface it is, you don't have to do this integral. That seems like a very complicated integral, right? You take the surface element, take the electric field, take the dot product, add them all up. But this is the theorem is that it doesn't care for what that is. Just count the number of charges inside. How many charges are there inside this? Zero. So that will be equal to 0 for this integral. That's the strength of that statement. Pick any surface. If it encloses, then you will have Q. Otherwise, it does not have the Q. So it's a very universal, if you think about it in an abstract sense, how does the inside part have the, or how does the surface almost capture everything about the inside? That has to do with the continuity of this function. If you think of a continuous function, if I know the functional value at one point and all its derivative, then you have some information about the function at another point also. So that's mathematically strong statement. So that's the integral part. But now let's think of it from the differential point of view. It's a differential point of view. There's no volumes, correct? There's only one point. Right? And now let's again look at this equation and stare at it and try to answer me. Suppose so there is an electric field here, right? So let's say at this point, that's a point. Right? That's my R. I know this electric field. Right? I take the divergence of the electric field at this point. Okay. What will I get?
Say that one more time.
So I pick any point in the space. So let's say this point, right?
Mm-hmm.
Let's say it is 1 meter away from the charge. I know the formula for the electric field, correct? I do this divergence of the electric field. With the mathematical guy, I had to do that calculation, right? I'll get some number on the right hand side. Right? In fact, think about what this is. That's where your answer lies. But the connection is to do about this. That's the idea of divergence. So my question is, at this point, physically speaking, because there's a point short, what will I get on the right hand side? So at this point,
The charge density divided by epsilon naught.
yeah, that's correct, but maybe a little more precise.
So the volume of the sphere around that point charge divided into the charge.
Careful. Thinking correct, but like that's I'm thinking more in the integral form. That's good, very good. Translate it into the. Try again. Yeah, it's good. What's the right hand side equal to at this point? What's the charge density there?
There's no charge there, so there can't be a charge density there.
Good. So
So 0.
0. It is 0 here because there's no charge there. What about here?
It's also 0.
0, 0. Everywhere this is 0. It's 0 everywhere except at one point where the charge sits. So if you do this calculation, so that's extra credit, let's say, 2 more minutes, evaluate divergence of this. Okay? So evaluate divergence of 1 over r squared. That's also your homework, by the way. It shows up in your homework, but this is an extra credit. I don't know how many extra credits. I don't track the extra credits myself. So if one of you guys gives it, that becomes an extra credit problem. If no one gives it, I don't try. Is that clear, the question? Evaluate this. And as I said, it should show up 0 everywhere except at one point. What will it be at that point? So you answered it correctly that it's 0 everywhere. What will it be at that point? What will it evaluate to? What is the charge density right where the charge sits? Charge per unit volume. What's charge? It's Q. The volume.
At a point, there's no volume, so.
0, right? So it should be infinity there. So you should see all those things coming out if you evaluate that. It better show up. If it doesn't show up, it's wrong. Your work is wrong, right? So try to see how you get the 0 and infinity showing up in this. That's one of the most important concepts in this whole semester. 0 and infinity showing up together. Right? Try to get that. No problem if you don't get it, but think about that. And let me stop. Thank you. Any questions otherwise? It was all not organized, so hopefully we will go smoothly on this time. It won't be so random thoughts. And feel free to talk to me in my office, or usually I'm available. Feel free to. Comments in general? The names Michael, I think I know. Oh yeah, Rob, Rob.
So we'll turn in the extra credit questions online.
Online.
Okay.
It's extra credit online. It's already available. Homework probably not yet there. Homework, if you are in the class, I will encourage you guys to submit it. Homework, I will prefer if possible, give me a hard copy, unless you're outside, you're not fine. But extra credit posted online because I don't want to give you. I mean, that's just to give you boost your grades. That's honestly that is to boost your grades and to motivate you a little. So I found a way to boost your grades by trying to. So, okay, that's all.
So this course will be electrostatics and magnetostatics.
Yes, I'll do a lot of electrostatics and hopefully a little bit of magnetostatics. Often what happens is that magnetostatics gets overflows into the next semester, but this time I want to pull it a little again with the conditions that it's and a little ambitious. And the next semester will be special relativity and dynamics basically together. Radiation, like if something accelerates, if a charge accelerates, it radiates. An important concept. So we'll talk about that. Okay. Thank you. Thank you. You assemble it all the time. Work.